defining the loads. Click load case details, then click add. Then for the primary loads, place here, the first one should be seismic. So let's just say this is EQ in X direction. Then click add. Next is earthquake in Z direction. Then click add. Next is dead load. So let's call this one DL. Then click add. Then live load. Let's have this one as double L. Then click close. So for the earthquake, let us add the load for the earthquake. So click the EQ in X, then click add. Then click the seismic loads. Then since we are defining here the earthquake in X, so the factor should be X direction. The factor is 1. Click add. Then for the Z, click add. Then look for the seismic load. Then Z direction. And the factor is also 1. Next is defining the dead loads. Click DL, then click add. The first one is the self-weight, Y direction, and it has a factor of -1 because the load is going downwards. So click add. Then you can see here a question mark, which means that this load has not yet been assigned to any member or any location of your structure. So what I will do is assign to view, meaning this self-weight will be assigned to all the members of the structure. So assign, yes. Then click dead load again, then add. Then first we define the floor loads. For the dead load of the floor, the unit weight, let us have the slab unit weight to be 23.6. This is taken from this one, table 204.1 or -1 of the NSCP. So for reinforced concrete, stone including gravel, the unit weight is 23.6. So 23.6, then the slab thickness is 0.1. So the uniform load is just the product of the two. So you have 2.36 kilopascals. So the pressure is -2.36 kilopascals. Unlike in the seismic, we place here a negative because we need to account for the direction of this load. Whereas in the seismic load, we are only accounting for the mass of the entire structure. So let us now have the ranges. For the Y range, we start at this point here. So we start at node 19, Y coordinate 2.1. So the minimum is 2.1. And the maximum is at this point here. The coordinates is 12.025. 12.025. For the X direction, we start at here. So this is 0. And we end here. The X is 22.7. So 22.7. Then for the Z, we start at 0. Then we end at this one, node 31. This has a value of 9.5. So from 0 to 9.5. Okay, so this is assumed to be a two-way slab. Or you can also have a one-way slab for the corridor and two-way slab for the inside of the classroom. But for this example, let us just have a two-way slab for all the slabs. So add. Then you can check if you have defined correctly the load by clicking this one. So you can see now that all the slabs are loaded from ground to 4th level. So that is how to define your dead load or the weight of the slab. Then I will add again another load, this time around for the ceiling load of the roof level. So I will add here a floor load, and I will assume the ceiling load to be half of the load of the slab. So the load of the slab is 2.36, and I will divide it by 2. So that will be 1.18. So negative 1.18. For the Y range, I will have a minimum. I'm loading here. So the coordinates is 15.225. So we have 15.225, and then the maximum also is 15.225 because we are only loading one slab. For the X range, same, 0 to the last point here has a coordinate of 22.7. So 22.7. Sorry. Then for the Z, we start at 0 and the end part is 9.5. So from 0 to 9.5. So let us check if the load is being loaded correctly. So here we can see that the roof level has a uniform pressure and it is loaded as a two-way slab to all the members. Next, we will load all the partition loads. So the partition is a masonry wall. If you look at the architectural plan, this is the configuration of the partitions, exterior and interior. Exterior partition is here. Interior partition, here we have 2. And then there are minor partitions here, which we will not include in the model. So we will only include the exterior partition and 2 interior partitions. So according to NSCP, table 204-2, minimum design dead loads. We have here for concrete masonry units, the density is 16.5 kilonewtons per cubic meter. So here we have the unit weight to be 16.5 kilonewtons per cubic. Thickness is 0.15 or 6 inches. Then the height, we will assume it to be 3 meters. So if we multiply the three values here, we can generate the uniformly distributed load across the beam. So the value is 7.43 kilonewtons per linear meter. Going back to the STAAD. So let's add a member load. The weight is negative 7.43, and then it is situated in the global Y. Then click add. Then select all the members where you are going to assign the loads. Let me do this in this manner. So those are all the beams which will be loaded with partitions. So view selected objects only to be sure. Inspect. And if it looks good already, then you can click the uniform load and then assign to view. Assign. Yes. Okay, so your beams now have uniformly distributed load of negative 7.43. Next is we define the live loads. So here we have live load. The same procedure. Click add. Then click floor load. And your live load will have a value which is based on NSCP provisions. So here we have from table 205-1 minimum uniform and concentrated live loads. This is for schools. So schools, inside the classroom we have 1.9, corridors and above ground floor we have 3.8, and ground floor corridor we have 4.8. So let us follow this one for our live loads. So let us first load inside the classroom. So it has a value of negative 1.9. Then for the Y, we have minimum of 2.1 to a maximum of 12.025. Then for the X, we have 0 to this last part here, 22.7. Then for the Z, we only load up to this point here. So the Z is only 7. So maximum is 7. Then let's add. And let's check. So indeed the load is only loaded inside the classroom. Okay. Next, we define the live load for the corridors. Click add. Then floor load. Then for the corridors, 3.8. So we have negative 3.8. The minimum for the Y range is 2.1 again, up to, again we have 12.025. For the X range, we start again at 0 and then we end at 22.7. But for the Z, we don't start at 0, but we start at this node here. So that node is having a Z coordinate of 7 and ends in at 9.5. So from 7 to 9.5. Click add. Sorry. I have accidentally clicked another software. Okay, so here you can see the Y range for corridor having a value of 3.8 is already loaded here. The blue colored load. Okay, so that is pretty much how to define the live loads or the building loads.